right, so this is a Lab 4 presentation. Right now we'll be going over a diagram of our blockchain system. We have these verifying nodes, and the verifying nodes task is basically what a miner does. It is able to go and grab a transaction from a global UTP called the transactions file and add it to a local buffer, a local UTP. It then picks a random transaction from its local UTP and go ahead, mines the transaction, tries to generate a nonce and a proof of work. And once it finds a proper proof of work, it'll add it to its local VTP. And it'll also add it to a global VTP, which will notify other verifying nodes to start and actually add that transaction to their VTP. And so we have all of these other verifying nodes which are mining alongside this original verifying node. The blockchains.json file is used for debugging, and it's basically a file which stores everyone's current ledger, so current local ledger, so that we can see how people's ledger looks like at any point in time if you want to, as well as the end of all of our transactions. So this kind of provides a little bit of context about our whole system. And so, yeah, so the next thing is the transaction definition.
So this was for our task 1. It was relatively simple. We basically just created this transaction class, and it has all the necessary fields that the transaction file.json also has. So like number, type, input, and all that. It also has a couple extra fields like previous transaction number, nonce, and proof of work that our nodes will be using, and some helper functions to help us properly represent these objects.
All right, we have a node class, which is going to be representing either a verifying node or a general node. A general node in this case is anyone who isn't going to be mining. So anyone who's just going to be making transactions, but is not going to go through the work of actually generating a proof of work by calculating the proper nonce. We have just a couple methods. We have the run method, which will just be pulling new verified transactions. New verified transactions, what this means is we will be grabbing from the global VTP and going through the proper steps of ensuring that the transaction is in fact having an input that exists, having it not being double spent, and ensuring that the trans and merge and those sorts of parameters are properly set. We also check the signature, and we also check that the input amount is equal to the output amount, and we also ensure that the proof of work is correct, because this is a global VTP that we're pulling. And so here we have the valid proof of work function.
And then for the verifying node, it's pretty similar to the original node, but this time we're pulling unverified transactions from our local UTP in a loop. So we start off by pulling a random transaction and then doing all those checks to make sure that this transaction is valid before we add it to the VTP. And then in addition, this verifying node can also perform the mining. So it can do the mining, and then once it's generated that nonce and proof of work, we can add it to its own VTP and notify all the other nodes, as well as perform the transaction pruning.
Exactly. And so when we go ahead and add it to the different ends of our local blockchain, because there might be forks in our blockchain, anytime we end up adding a transaction, we always call a prune transaction operation. This prune transaction operation, as you can see, is specific to the VTP. And what it does is it essentially goes and actually prunes off any smaller branches, as long as the branches have a length of 5 less than another branch. So if you want to see how that looks, we have it right here. This prune transaction, as you can see right here in this if statement, we basically are able to detect whether or not a branch is short enough for it to be pruned off, and we actually remove it from our VTP and re-add it to our local UTP. So that's the prune transaction. And then we have our create transaction file.py.
So our create transaction file is basically doing task 3 and task 4 in one go. We're creating all these verifying nodes for 5 different users. And then we have this create transaction function, which can generate the transactions that will be stored in the transactions file.json. So we pass in input, output, and it'll generate the number and the signature. So here, obviously, we have our Genesis transaction as first, and then we generate a total of 10 transactions, testing out the transfer transaction, join, merge, as well as a few other edge cases, such as if the transaction is double spend, we don't want that added to the VTP. If the transaction has an invalid signature, or maybe the input amount is differing from the output amount, then we also want those transactions to be detected as invalid.
Cool. So once we've actually created those transactions, like Jason said, we add it to our transaction file.json. And then what will happen is we start our actual threading. So for each of those nodes, we have a run function, which is actually performing all of the mine operations and kind of the retrieving and basically doing the job of a verifying node. We create these 5 threads for these 5 nodes and we start them. And if we go ahead and actually, I'm not going to run it just yet, but we're going to take a look at a previous run, and this is the output of that run. I'll show it running a little bit later down the line. As you can see here, the first transaction that we see is Alice is able to actually receive a new unverified transaction, and she adds it to the UTP. Since it's the first transaction in the transaction file, it is just so happens to be the Genesis block. And you can see that on line 26, Alice looks at that same transaction, adds it to the UTP or VTP because it is a Genesis. All of these other people, Bob, Charlie, all these people end up adding this transaction as well and add it to the VTP directly because it's a Genesis as well, as you can see right here. Now, later down the line, you actually see a couple the cases edge cases that Jason was mentioning. We can scroll down a little bit and just look at those edge cases for a little bit. The first edge case, I believe, is whether or not the transaction is double spent. And so you can actually see here in this case, that transaction that we specifically made double spent has been able to be detected by all of the different people as being double spent. So they won't add it to their VTP as well. The transaction that has invalid signature, it was actually able to, all these people were able to detect that that transaction has an invalid signature and therefore they didn't add it. The transaction that has an invalid amount, so this transaction, as you can see, everyone also was able to detect that it has an invalid amount and therefore did not add to their VTP. You can also see in general how these people are able to actually go and mine. For example, EU starts mining for this transaction, and everyone else also starts mining for this transaction, but Alice was the one to actually finish the mining for this transaction. In this line, you can see right here, same transaction, but she says that she finished mining and she added it to her VTP, and she also printed out the previous block linked to this in the blockchain. And she notifies all the nodes, all of the other nodes, as you can see in these 4 lines, get notified and they add it to their VTP. And they also mentioned that they've been beat to added this to their VTP. So you can see the whole process of this blockchain kind of working in this output. And yeah, so to run it, what I'm going to do is I'm going to modify the code right now just so that our proof of work's a little bit easier to run, and I'll come back and I'll be able to actually run it and show you exactly how it works. Because right now the 5 zeros.
Already did that.
Okay. Oh, cool. So it's already done. So Jason's going to actually run it right now, and you'll be able to see the output down here. I hope it doesn't go over the time limit, but if it does, then this is just the same output as before. So you can actually skip it if you want. But this is basically all of the transactions are being populated and mined. For example, if we take a look at this blockchains.json file or verified.json file, you'll actually see new transactions being added as time goes by. So for example, everyone's mining right now. We're all stuck on mining. Someone eventually will have finished mining. And as you can see just now, they have added it to the global VTP.